All right, so this is our continuous compounding formula. It is B is equal to the principal E R T. So R and T are raised to the power. E is a button on your calculator. So if you're using my calculators, it is going to be the blue key, so the second key, and then the one that says, see that little E to the X power? Your exponent, that's the one that we're going to be using, okay? On your calculator, you need to find that button. And if you need some help, I can show you here in just a second, okay? So nothing too fancy. We're just going to do some practice problems with it. So what we're going to start with, let me explain what we're looking at, okay? So this is our exponential growth formula, all right? What happens is with our money is that it starts to grow a little bit, but then slowly it starts to do this. Starts to go really, really, really high, really, really fast, okay? So the idea of this is, where are we going? Okay, so we can measure how much money we have at a certain time, but the overall idea is that we are going to be making lots of money, okay? So basically what happens is this. So as x, which is our variable here, as x goes to infinity, right? So that means that we're thinking of not just x down here at like 10 years, we're talking x millions of years down the road, okay? We're saying that f of x, what was f of x again? That's just a fancy way of saying y, correct? Okay, so f of x approaches infinity, okay? And why is it approaching infinity? Well, because the graph is curving up. Excellent, good job, all right? So then if I do this, right? So think about this. So as x approaches infinity, where's f of x going to? Not negative infinity, really close to 0. All right. Will it ever reach 0? Nope. Because it's something called an asymptote. And with an asymptote, you never ever cross it. You get really, 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 really close to it, but you never ever touch it. Do you have an older brother? Are you the older sibling? Do you ever play the game not touching you and you get really close to their face and you just sit there and not touching you and it drives them crazy? That's what this is like. You're getting really, really, really close. Mom, I'm not touching him, but I'm getting really, really close. But I'm not touching him though. Drives them crazy, right? Mm-hmm. And we'll do a therapy session later. Okay. Now, oops, that should be dashed. All right. So this guy right here. Okay, so as x approaches infinity, right? F of x approaches what? 4. You can see how it's got this little asymptote right here? And I see that it's at 4. It's going to be approaches 4. All right, so I'm going to go back up to my give you a second on this third one, then I'm going to go back to my first example. All right. There's a way we can talk about this. Okay. So in Algebra 2, we call this and behavior. Okay. In pre-calculus, and what you guys are going to see on your assignment is this. You're going to say the limit as x approaches infinity. And where are we going? Where was the end behavior on this one? Infinity. So the limit of f of x as x approaches infinity is infinity. Okay. So if I do the same thing here, the limit of f of x as x approaches infinity was 0. So the limit of f of x as x approaches infinity is equal to 4. And you guys have just been taught a little bit of pre-calc. Nope, it's not. I know, but we're going to be quiet about it. Okay, so highly. You're supposed to say highly. Can I change it? Okay, sorry. Okay, wait. Okay, so this example here, little coordinate plane. I'm just testing you. You guys passed. Good job. All right. Okay, so there's my f of x. Okay. So we're gonna go right into the limit. The limit of f of x as x approaches infinity is equal to infinity. Good job. Okay. So there was an example of one that goes to infinity. Now, I'm going to show you a little shortcut, okay? Yeah, because I think you guys can handle it. All right. What you're going to see as x approaches infinity is we can actually take two functions and we can divide them, okay? So if I just cover this up, in Algebra 1, Algebra 2, probably in geometry, you had to graph that, correct? Yeah, you would. I know, I'm giving you flashbacks, okay? So now what we're doing is we don't really care about what the graph looks like. We just want to know where is it going? What's its end behavior, okay? So what we get to do with this is you actually get to ignore this part, okay? You get to ignore the 9 and the, you got it. So Quentin, what was the word you used? What's a coefficient? Correct. So the coefficients are what we care about. Okay. So what you're going to do is you're just going to take your coefficients and what is 3 over 6 reduced to? 1/2. Okay. So my answer, because that's what everybody wants to know, is this. The limit as x approaches infinity of 3x plus 9 divided by 6x minus 5 is equal to 1/2. That means that the graph, as we go further and further out on the x-axis, is getting infinitely closer to 1/2. That's all that means. Okay? That's good. That's my plan. Okay, now What we're worried about, all right, now why the continuous compound function is important is that if we get stuck into like that blue, the uh, the blue blueprints machine, if you keep running it through, it's never going to stop. But the paper reaches its absorption factor and it just falls apart. Okay, so eventually there's a limit. What this is saying is that there is no limit to the amount of money you can earn, or excuse me, or what you owe. So the credit card companies could, by definition, charge you forever, and you would never ever get out of credit card debt. Okay. Okay, so just to kind of get you a little practice with this, we're going to say that our principal is $5,000. Let's do a rate of 2%, and let's do a time for 7 years. Okay. So the B doesn't change. My principal is 5,000. We're doing exponential growth. My rate, I need to make sure that it is a, thank you, and that my time is always in years again. Thank you again. Okay, so then what we're going to do, now I can't decide, well, I guess if I unzoom it, yeah, we can get it. All right, so we have $5,000, correct? I'm going to hit second and then come down here, hit the E button, and notice that it puts me up into there. My rate was 0.2 times by 7, and my after 7 years, 0.02. Yep, you're correct. That would be my ending balance. Okay, so the question I have for you now is, what's my interest earned? Perfect. Okay. So what we're doing is the question now is, what's the difference in the interest earned of the principal amount of $2,000? Scoot that over just for a second. At a rate of 3% for 3 years. I want you to calculate the simple interest, the compound interest, and we're going to compound it monthly and then compare it to the continuously compounded. And we only want to look at the interest, okay? Okay, so this is the 3 calculations we did. We did simple interest. The interest earned here was $180. Compounded monthly gives you interest rate of 188.10 cents. And then continuously is just 188.35 cents. So it's only 25 cents more than what you did if it was compounded monthly, all right? Excuse me. And what you got to realize is that this guy here has to be growing for a longer period of time for you to make more money, okay? And if that happens, then that's how you're going to get more of your money, okay?